In this video, we're going to talk about the radiation and the types of the radiation. The atomic structure looks like this. It has a nuclei in the middle, and there are some electrons which are running around this nuclei. Let's look to the structure of this nuclei, basically, and we can see that it contains of the neutrons and the protons. So the protons are the positively charged subatomic particles, protons, and the neutrons are neutrally charged subatomic particles. And every element in the periodic table of element has two numbers, and those number basically indicates the number of the protons and the neutrons this element has. For example, the radon was the numbers 86 and 222 means that it has 86 protons inside its nuclei and 222 elements, subatomic particles inside this nuclei in total. So basically the number of the neutrons plus the number of the protons is going to equal to 222. So we know so-called electromagnetic force, it tells us that the two particles with the same charge are pushed away from each other, right? So then the question is why those particles, okay, the protons with the same charge are not taking away, pushing away from each other. So there is so-called mysterious force, which is called the strong nuclear force, which keeps this balance and which helps those particles to keep together. So this nuclear force is 100 times more stronger than the electromagnetic force. So it helps the particles to keep together inside this nucleus to create this stable nuclei. The problem is not all the nucleus are the stable nucleus. So we can see unstable nuclei, unstable nuclei. So basically, depending on the number of the particles or the bad combination of the number of the neutrons or the protons, this nuclei might be unstable, basically, where the strengths of the strong nuclear force becoming smaller than the strengths of the electromagnetic force, for example. Then this nuclei. So let's assume that this nuclei has too many particles inside, where the strengths of the strong nuclear force becoming smaller, then this nuclei starts to stabilize itself by giving out some of its particles. And this process is called the radiation. So the radiation is when the unstable nuclei tries to kick off some of its particles in order to become more stable. And so depending on how many particles it tries to give out from its nuclei, we're going to differentiate the types of the radiation. So basically to the alpha radiation, to the beta radiation, or to the gamma radiation. So let's consider the first case, the alpha radiation or the alpha decay. In this situation, the unstable nuclei tries to give off 4 particles, basically 2 protons and 2 neutrons, so that it becomes more stable. And this particle was the this particle was the 2 neutrons and 2 protons is called the alpha particle, or the helium. So the helium is going to have 4 particles in total and 2 protons. Or the alpha particle is going to have 2 protons and 4 particles in total. So let's choose some example. For example, the radon with the 222 neutrons and protons and 86 protons can emit the alpha particle, can do the alpha radiation. In this case, the alpha is going to have the 2 protons and 4 particles. The atomic mass of the alpha particle is going to be 4. So the question is, what is going to be here the element, right? So this element should have 84 atomic number, right? So that the 2 plus 84 should be equal to the 86, and the atomic mass should be equal to the 218, right? So the number of the protons should be equal to the 84, and the number of the neutrons plus the proton should be equal to the 218, and this is polonium. So the radon becomes into the 2 parts, so it becomes more stable by transferring from radon to the polonium. And there are some particles, the alpha particles, which are emitted in this process, where we call this as a alpha radiation. So there is another case when the nuclei is unstable, is when we're going to have too many neutrons inside this nucleus. For example, if the nuclei has too many neutrons, for example, let's assume that this is the structure, so too many neutrons, so that it's unstable. So some of its neutrons are spontaneously becomes a proton. So basically, let me draw the same structure. So we used to have only 2 protons, and for example, this particle becomes also the proton. Some of its neutrons spontaneously becomes a proton, so that it stabilizes itself. So this is unstable. Now this one becomes stable, but it emits some particles as well, right? So in this case, it's going to emit the electron with the negative charge and with the mass 0, or we also call this as a beta negative with a 0 mass, because this positively charged proton with this negatively charged electron is going to give us actually the neutrally charged neutron, right? So this kind of radiation is called the beta negative radiation, or the beta negative decay. So this works for the situation when the nuclei is unstable because it has too many neutrons. But it's possible that the nuclei is unstable because it has too many protons. So for example, it has too many protons, and some of its protons spontaneously become neutron in order to become a stable nuclei. In this case, so too many protons. So that the atom becomes, so nuclei becomes in this case like a proton, and 3 neutron. Some of its protons become spontaneously neutron. In this case, it emits a positron with the positively charged and with the mass 0. So as you can see that the nuclei, the neutron was the neutrally charged particle, with this positron, which is positively charged particle, is going to give us the proton, right? So the unstable nuclei is going to become stable when the proton spontaneously becomes a neutron and it emits the proton. This is called, again, the beta radiation, or beta negative or positive radiation, because in this process we're going to emit the positive beta particle. In this case, well, we're going to emit the negative beta particle. And there is a third case when the particles which are highly excited are going to emit some energy in the case of the gamma particle or in the case of the gamma photons. So I've got the unstable nuclei, and it's going to just emit the gamma photon with the zero charge, with the neutral charge, and with the zero mass. So let's do a couple of, let's write down the summary for what we've learned so far. We talk about the radiation. So we say that the radiation is the process when the particle emits some, so when the nuclei emits some particles in order to be stable. The unstable nuclei emit some particles in order to be stable nuclei. And depending on which particle emits, we are going to have different types of the radiation. So we've learned about the alpha radiation. In this case, we are going to talk about this alpha, beta, and gamma radiation by change in the mass number or in change in atomic number. So whenever the alpha radiation happens, the change in the mass is equal to the -4, and change in the atomic number is -2, right? So we've considered an example. So if one element with the atomic number 86 and 222 atomic mass, it emits the alpha radiation. It becomes alpha 2 and 4. So it becomes a polonium with the atomic number 84 and with the atomic mass 218. So its mass is decreasing by 4 and its atomic number is decreasing by, so its mass decreasing by 4 and its atomic number decreasing by 2. So we'll talk about the negative beta radiation. In this case, the change in mass. So there is no change in mass because so whenever the beta radiation happens, it's when the proton becomes, so neutron becomes a proton, right? So there is no change in the mass, but the atomic number changes. For example, if some element has the 7 protons and 12 atomic mass, then this is going to have 12. So some of its protons, some of its neutrons becomes a proton. For example, in this case, it's going to be 8 plus the electron with the atom, so with the mass 0 and with the atomic number -1. Some of its neutron becomes a proton in this case, right? So the change of the atomic number is becoming +1. And the beta plus radiation, it's when the change in the mass is 0. There's no change in the mass, but there is change in the atomic number, it is minus. So the beta plus happens, it's when some of the protons becomes a neutron. For example, if the element is 7 and 12, so that it becomes the element 6 and 12, plus the positron with the positive charge and 0 mass. So in this case, the atomic number decreases by 1. And there is a gamma radiation when the no change in the mass and no change in the atomic number happens. So far, we've learned about the 4 different types of the radiation: the alpha, beta negative, beta positive, and gamma radiation.